Today we're going to start a 2-day kind of exposure to something called rational expressions. The basic idea of what we're doing is that we are going to take the polynomials we've been working with and we're going to put them into a fraction. Okay? So there's going to be a polynomial on the top of a fraction in the numerator and a polynomial in the denominator. And then we're going to be reducing things, looking for stuff like that. To start with, we're going to talk about a word that I suspect you've heard before. The word is domain. The domain is the set of all input values that are allowed for your expression or equation if you were working with an equation. We're working with expressions. In particular, for what we're working with, because we're working with fractions, what number do you know that you are not allowed to have in the denominator? A 0. The denominator cannot be 0. Division by 0 is called an undefined operation. So for what we're working with, the type of problems we're working with, we're going to be in particular looking for what value would actually make my denominator 0, and that number is not going to be allowed. Okay? So we'll do an example of one. The directions say to find all excluded values for the expression. So, in general, the denominator might look something like this, 12 minus 3w. And what we want is we want to know, where does 12 minus 3w equal 0? And in particular, we don't want that to happen, so we're going to write does not equal 0. And we're going to solve it just like it was an equation. So what would you like to do first to solve this non-equation? Okay, subtract the 12. So now I have negative 3w does not equal negative 12. And then what? Divide by negative 3. So what value can w not equal? 4. And if you take a look back at the expression you were given to start with, if you plugged in 4 for w, would you in fact get a 0 in the denominator? Yeah, you would. So this is the excluded value for your problem. Can't let w equal 4. Okay? The next thing that we're going to take a look at, and it's going to just be prevalent throughout everything else we do, is a reminder of a fact that you know about fractions. So in particular, you know that if you have c times x over c times n, that what happens to the c's? They cancel out, right? If there is a value in the numerator, and there is a condition, of course, c can't be 0. It doesn't even make any sense to talk about it if it is. But any other number, any other variable, just not 0. If it factors the numerator and it's a factor of the denominator, it can cancel out if it matches. So as we simplify our rational expressions, that's what we're going to be looking for. Now the first one is already in factored form for you. What do you notice matches in terms of the factors in the numerator and the factors in the denominator? The 3u plus 8 identically match, so they cancel out. It's a factor because it's in parentheses being multiplied by the other pieces. Is there anything else that divides or simplifies from here? Yeah, the 8 and the 48. Okay, those are just numbers. What do they both divide by? 8, yeah. So 8 divided by 8 is, of course, 1. What is 48 divided by 8? 6. And these directions actually say, which is a super nice thing for us to be able to do, to leave our answers in factored form. Now, why will the u plus 3 and the u minus 5 not cancel? They're not the same. They both have a u in them, right? But they're separating with the addition and subtraction, and they don't match identically within this set of parentheses. So I can't reduce them. I will still have a u plus 3 on the top, and in the denominator, I will have a 6 times u minus 5. And the part where it said leave your answer in factored form means that they don't want you to multiply the 6 through the denominator. They want you to just leave it in factored form. And the reality is that that's a more pleasant way to leave it. Number one, because it's less work for you, fewer mistakes to be made, and so forth. And number two, if you were being asked to do something further with this, it would already be in a form that's easier to work with. For example, looking at it like this, what can you not equal? Nope, u equal negative 3 would be okay because it would give you a 0 in the numerator, which is fine. But you can't equal 5 because if I had a 5 right here in the denominator for u, I'd get a 0 in the denominator, right? It's easier to see that if it's written as u minus 5 than if it's written times the 6, than if it's written as 6u minus 30. If I write it as 6u minus 30, it's much more difficult to see what the value is that u can't be. Okay, now we're not asked to do this in this problem, but I'm trying to show you why it is that leaving it in factored form is actually a more desirable answer choice, okay? So our answer would be u plus 3 over 6 times u minus 5. So I did one example, number 2 here, where it's already done in factored form for you. Everything else we're going to do today, we're going to have to do the factoring to start with. So it's super fantastic that you guys have been doing multiple lessons where you've been learning to factor, because now we're going to utilize that skill. So take a look at each of these. How in the world can I factor the numerator? What do you see? I can pull out a 5. Anything else can I pull out? And a u. So if I factor a 5u out of the top, what will I have left? 3u minus 2. Is everybody good with that? How about the denominator? The 5u. And if I take out a 5u, what do I have left? U minus 5. So what will reduce or cancel from the top to the bottom? The 5's, good. Anything else? The u's, yeah, this first u anyway, yeah? Yeah, not all the u's, but the first one, well. The 3u minus 2 and the u minus 5, can those simplify? No, they can't, right? There's no number or value that's common to all of it. So my answer is simply 3u minus 2 over u minus 5. Okay, are we good with that? Okay, let's try another one. Number 4. Number 4 was a lot like the last question on your quiz. What do we call that problem? It's close. Not a perfect square, but a difference of squares, right? It's difference because it's subtraction. It squares each individually. So how would y squared minus 16 factor? Y minus 4 and y plus 4. What's that? It is one of the difference rules that we did last time. Yes. It was the one that had a square. Had a's and b's in it. A squared minus b squared. And, of course, what we noticed then is that one of those cancels with the denominator, right? Yep. Y plus 4. So the end result on this one actually doesn't even have a visible denominator. I mean, it's a 1. That's fine, but I don't need it. I can write it as y minus 4. How about number 5? How will the numerator factor? Well, it's a trinomial, so I'm going to have 2 sets of parentheses. Lucky for us, it has a 1 at the beginning, so I have y and y. The negative 24 at the end means what? the signs are different. I'm going to need one of each of the signs. Now I need two numbers that multiply to 24 and subtract to 2. 6 and 4 will do it, right? 6 and 4 multiply to 24, subtract to 2. So do I want 6 and then 4, or do I want it the other way? This is the one, right? Why do I want it in this order? I need a positive in the middle, and this 6 is positive, this negative 4, so I get a positive 2 in the middle. Good job. The denominator, I'm going to do in 2 steps. Let me just do a step over here. What do they both have in common? There's a 2 in both of them. So start with pulling out what they have in common, which will then give me y squared, whoops, getting ahead of myself, minus 16, right? So the 2 will stay, but the y squared minus 16 is just what I did in problem number 4, isn't it? How does y squared minus 16 factor? Y plus 4 and y minus 4. And then what reduces? The y minus 4s. Anything else reduce? Nope. So I have y plus 6 on top, and then 2 times y plus 4 on bottom. Any questions on that one? All right, the next two are multiplication. But the reality is that multiplication really means we're doing the same thing we just did. We just potentially have 4 places that we're doing factorings and reducings. So these are, actually this particular one, number 6, is fairly nice because I don't have any trinomials. So I'm considering each piece one at a time. 2x plus 18. So how will that factor? By a 2, right? You can pull out a 2, which will give you 2 times x plus 9. Is everybody good with that? Now the reality is that when I multiply, it all becomes part of the numerator. So let's just keep moving across the top. I have 7x plus 56. How will that factor? I can pull out a 7. So I'm just going to put a multiplication dot and a 7. And if I pull out a 7, what am I left with? X plus 8, yes. Okay, ready for the denominator. X plus 8 doesn't factor, right? It's already in its reduced form. So x plus 8 will simply slide right on over. And then I have 8x plus 72. What will factor out of that? The 8, and it will be 8 times x plus 9. Okay, so all I've done is written all the multiplication parts on top, because that's what we do when we multiply fractions, right? We just multiply across the top, we multiply across the bottom. And then once it's like this, we can compare it from top to bottom. Okay, if you don't want to write it like this and you want to leave them as 2 separate fractions, you can compare across the diagonals and do the same thing. Okay, but which pieces of this will reduce now? The x plus 8s, the x plus 9s, anything else? The 2 and the 8 actually will as well. Here's a 2, and then the 8 will become a 4. What in the world am I left with? 7 over 4. I don't even have any variables on this one when I'm done. What's that?
Wow, so simple.
It is a very simple answer. My favorite is when you start factoring things and the answer at the end is 1, and you're like, wow, it's a lot of work for the number 1. Whoa. Okay. This one's a little bit trickier, number 7, because I do have some trinomials. They aren't, the hardest trinomials of your day for sure, but a couple of these pieces are pretty simple. I've got the x plus 3, of course, that doesn't factor. Sorry, typo. Yes, I do mean subtract. Okay, how about the second one? Need to factor this. So how will x squared plus x minus 2 factor? Well, there are x's here. And then what? What are my signs? A positive and a negative. Good. number's 2, which is prime, so it's just 2 times 1. Where's the 2 going to go? With the positive or with the negative? It's going to go with the positive. And again, how do I know? Because that x is a positive sign right there, right? So I need the 2x to be the bigger one. When I subtract, I'll get the smaller. All right, denominator. The first piece is x squared plus 2x minus 3. So again, at least I have a coefficient of 1, so they're both x's. What are my signs? A positive and a negative. And then 3 is prime again, so I only have one choice, 3 times 1. Where will the 3 go? At the beginning or at the end? Or in the first parenthesis or the second parenthesis? The first one. Again, I'm supposed to be getting a positive 2 in the middle, so I need a positive 3 and a negative 1 to make that happen. Last piece is 3x minus 9. How will that factor? Yeah, I can pull out a 3, and I'll be left with x minus 3. Okay, comparing from top to bottom, what reduces? X minus 3's. Yep. It's okay. That's it, yeah. So my numerator is x plus 2. My denominator is 3 times x plus 3. How are we doing? Pretty good? Okay, this really feels like just the same thing we were doing in the last lesson, just this one extra step of comparing and marking things out. That's what it should feel like, okay? No, because the directions just say to leave it in factored form.
Oh, okay.
Yep. So, right, I didn't mean to mark out that. I meant to highlight it to leave the answers in factored form, yeah. So we'll leave it.
The directions say factored completely.
Yes, if it said, well, if it says factored completely, it means you leave it factored. Yeah. So for what we're doing, just leave it all factored at the end. You're in good shape to leave it there. Yeah. All right. What if it's division? What do you remember about division of fractions? You multiply the reciprocals. So the very first thing we're going to do when we have division is to flip which fraction? The second one. Good job. You guys must have had a good teacher about that. So we're going to have 9x minus 27 on top and 5 on bottom. That's our first step. And then, lo and behold, the problem is just like the ones before, right? So, in the first one, I have an 8 on top, and then times. So how about that 9x minus 27? What do they have in common? A 3. Bigger. They do have a 3 in common, but there's something bigger. A 9, actually, right? Okay, so I actually have a 9 in common. 9x would be x, and 27 would be minus 3. Is everybody okay with that? Remember, we're looking for the biggest thing they have in common. The denominator, 3x minus 9. What does 3x and 9 have in common? That one's a 3, which gives me an x minus 3. And then I have times the 5 that was in the denominator already. So what reduces? The x minus 3's. Anything else? Yeah, this 3 and this 9 would reduce to give me a 3 up here. So what do I have now in my numerator? Which is 24 over 5. There's another one that showed up at the end being just numbers. All right, I'd like for you to give number 9 a try on your own. It's kind of like the culmination of everything. Okay, give it a try, take about a couple minutes, and then we'll confirm and make sure everybody, check with the neighbor and all that good stuff, has the same thing. when you get to the stop spot, see if your neighbor's there, and you can check with them that you have the same thing. Okay, did you compare and people get the same answer? Did we get to that spot? I'm seeing some nodding heads. What did you do first? Flipped it, the second one, right? Yeah. So you should have flipped the second fraction. So now I have 3x plus 6 on top, and I have x minus 2 on bottom. After that, I'm going to factor. How does the first one factor? I'm going to run out of space over there. Move it down here. How does that numerator factor?
X minus 1 and x minus 2.
Good. X minus 1 and x minus 2. They need the same sign since it's positive at the end. And that sign needs to be negative because it's negative in the middle. 2 and 1 will make that work. How about we're going to just continue across the top. 3x plus 6. Pull out a 3, and I'm left with x plus 2. Good job. Okay, denominator. X squared minus 5x, plus 5x plus 6. X plus 2 and x plus 3. That will give me a 6 at the end and a 5 in the middle. And then the x minus 2 doesn't need any factoring. So what reduces? X minus 2, x plus 2, and that is it. So on the top I'm left with 3 times x minus 1, and on the bottom I'm left with x plus 3. Any questions on that one?